Assalamualaikum and hi everyone. This is pre-recorded video 8 for chemical bonding. In previous video, we have discussed the properties of bonds where shorter bonds is stronger and need higher energy to break them. Those bonds are intramolecular bond and they are very strong. In this video, we are going to learn an interesting subtopic, intermolecular forces. Intermolecular forces are attractive forces between molecules that generally are much weaker than covalent bond. It is also known as van der Waals bond. Please be careful when you spell van der Waals, W-A-A-L-S. The wrong spelling is not accepted because it's a special name. So how many types of van der Waals are there? Intermolecular forces has three types. However, the first two types are van der Waals. Then comes hydrogen bond. Please be careful with the name of intermolecular forces here. They are quite confusing. Okay, the first one is dispersion force. In some books, they use another terms like induced dipole bond and also London dispersion force. They are a type of van der Waals. The second one is dipole-dipole bond and also a type of van der Waals. The last one is hydrogen bond. The strength of these three bonds are stated in this slide. We can see hydrogen bond is the strongest and London force is the weakest. However, those intermolecular force bonds are much weaker compared to a true covalent bond. This is an analogy of intermolecular force. Even though the bond is weak, it holds the molecule together in solid and liquid phase and allows gases to condense on cooling. Other than that, it prevents instant evaporation during hot day. In this video, we are going to focus on the first type of intermolecular forces, dispersion force or London dispersion force, or sometimes it's called induced dipole forces or van der Waals force. Let's just say that this force is occurred to non-polar molecules, where at the beginning the electron distribution in non-polar is randomly distributed. Then comes momentary shifts in electron cloud density that makes temporary dipoles. You can see there are parts of positive and negatively poles because of the momentary shifts, which is called temporary dipoles. So the attraction is in between positive and negative poles between molecules. So it was started with a molecule that doesn't have a permanent charge distribution like an argon here. Then induced temporary dipole is produced so that a London dispersion force can be shown there. This is when there are more molecules, making more London dispersion forces between molecules. Please take note that the larger size of the molecules, the more easily this temporary dipole to develop. It can happen in solid form like an iodine here or fluorine gas at room temperature. Let's take a comparison between methane, smaller molecules, and octane, which is a bigger molecules here. We can see the London forces is bigger for a larger molecules, which means more molecular weight for larger molecules. These London forces happen to non-polar compounds, basically molecules that do not have a permanent charge distribution within the molecule. For example, hydrogen. These are the molecules that have an even electron distribution, which are typically single atoms, molecules of the same elements, hydrocarbons, and symmetrical molecules. For example, neon, krypton, hydrogen, and many more. We also should note that molecules with high boiling point will have lower vapor pressure and the other way around. Since London forces is directly proportional to molecular weight and molecular weight is proportional to boiling point, so it means that London dispersion also contributes to high boiling point. That's all for today. Thank you. See you in the next video.